Alright, so in this problem, what we're going to be trying to do is to find the height of a balloon when a sandbag ballast is dropped from the balloon. So the problem reads, a sandbag ballast is dropped from a balloon that is ascending with a velocity of 40 feet per second. If the sandbag reaches the ground in 20 seconds, how high was the balloon when the sandbag was dropped? Neglect air resistance. Alright, so I've taken the liberty of putting a few things up here. The first thing you'll notice is that I highlighted the information that's given in the problem. So whenever you're trying to solve a physics problem, the first thing you want to do is to note what information you're given, right? And I've also written down the given information down here, right? V0 equals 40 feet per second, and T is equal to 20 seconds. I've also underlined the key information that we're being asked to find, right? How high was the balloon when the sandbag was being dropped? So it also tells us neglect air resistance, so you don't really have to worry about the sandbag slowing down or anything like that. Also, another key thing is we're using feet per second here, right? So when we're using feet per second, we have to keep in mind that G is going to also be in feet per second squared, right? So when you're using feet, G, the acceleration due to gravity, is measured at 32 feet per second squared. When we're using meters, it's 9.81 meters per second squared. But with feet, we have 32 feet per second squared. Now, if we want to solve this problem, what we want to do is we want to take a look at the free fall formulas that we can use to solve it, right? So we have four formulas here. The first formula is the height formula, right? The vertical height formula. Y equals V0t minus a half gt squared plus y0. Second is the final velocity. And the last two formulas are derived from these two previous formulas. Okay, so the derivation is actually on the website, pointclearphysics.com, and you can check it out. It's in the free fall section. And you could also find it online. So in case you were wondering about that. Now, the thing is, what we want to do is we want to use the easiest formula, the formula that for which we have the most information, right? We don't have to use a bunch of formulas just to get one thing, right? If you take a look down here at the fourth formula, we have y minus y0 is equal to v0 plus v sub f over 2 times time. We have time, right? We don't have the final velocity. We know the initial velocity, but we don't have the final velocity. We don't know what the initial height was, right? So there are two pieces of information that are missing here, right? As for y, we can figure that out, what y should be at a certain time, t equals 20 seconds, right? We can figure that out. But we're missing two key pieces of information here, right? So that's already not a good sign to use this formula. The second one above is not any better. We still have to find the final velocity, and we are also missing the initial height. Now, the second formula, this is not a final velocity problem, so we don't really need to use this formula. It's not necessary. Okay, so that leaves us with the first one, where in the first one we are giving time, we have the initial velocity. All we have to do is solve for y0, the initial height. And like I mentioned when we were talking about the fourth formula here, that y, we can logically deduce what y should have to be, right? At t equals 20 seconds, we know that y, the height of the sandbag, should be 0, because at t equals 20 seconds, the sandbag is on the ground. So y equals 0 at t equals 20 seconds. Okay, so y equals 0 at t equals 20 seconds. Okay, so we'll keep that in mind. So we're going to be using formula number 1, the height formula. Okay. Alright, so the formula we're going to be using is y equals v0t minus 1/2 gt squared plus y0, given that v0 is equal to 40 feet per second, and t, the time, is equal to 20 seconds. Alright, so we'll just go ahead and plug these numbers in, but we keep in mind that at t equals 20 seconds, y is equal to 0. So that means we have 0 is equal to 40 feet per second multiplied by 20 seconds minus 1/2 of 32 feet per second squared multiplied by 20 seconds squared, and then plus y0. So we just have to solve for y0 here. Now if we rearrange the equation, let's just switch the y0, bring it to this side, and we have y0 is equal to positive 1/2 of 32 times 20 seconds squared. Half of 32 is 16, so we have 16 multiplied by 20 seconds squared. So I'll just write the number and I'll put the units in later. So 20 seconds squared is 400, and then minus 40 times 20, that's going to give us 800. And this is going to be equal to 6,400 minus 800. And that gives us 5,600 feet. So y0 is equal to 5,600 feet.